Hello, everybody. Hopefully, you're doing well. In this video, we're going to take a look on chapter 3, graphing. In For intermediate algebra, one thing you need to understand, beside the basic, the four basic operations: addition, subtraction, multiplication, and division of real numbers, you would need to perform those basic operations on variables, on the different types of expressions, algebraic expressions, or radical expressions, or rational expressions. But graphing should be one of them. In chapter 2, we went over the linear equations in inequality, about only one variable. But in this chapter, we would examine a statement about two variables, linear equations and inequalities in two variables. We will focus particularly on graphs of two equations and inequality that lead to the notions of relation and the notion of functions, perhaps the single most important and useful concept in all mathematics. But we have different sections, but we're going to focus on in this video on section 3.1, graphing equations. Um, Reading graphs and the rectangular coordinate system. So I think that's where we're gonna start anyway. So we need to learn about the coordinates. One point has two coordinates, and you have the XY plane, or we call Cartesian plane. Remember the XY plane in this format where you have a vertical line that intersect with a horizontal line. The horizontal line, we call it X, and the vertical line, we call it Y. And it's intersect at the origin at the point 0, 0. When we have a point, the point has two coordinates. It has an X coordinate. The first coordinate is X, and the second coordinate is Y. So these two values from 1 point. So we can obtain 1 point. We always mark the x's on the horizontal axis. If you have 0 at the intersection, so below 0, that would be negative numbers like -1, -2, -3, etc. 1, 2, 3, and 4, etc. So above 0, that would be for the y values. I'm hoping so far you can remember these, but if you can, no problem, because we are just at the beginning of it, and you're gonna make use of all that. Of all of this. Determine whether an ordered pair is a solution to an equation, and also if the ordered pair is is located on the graph. Graphing linear equations, graphing non-linear equations. That's exactly what we would do in this section. So let's start very quick. With the rectangular coordinates I just told you about. So ordered pairs, two numbers associated with a point. The ordered pairs usually is x and y, two values in parentheses, not a bracket. The first coordinate gives the horizontal location of the point. So when we said if this is the horizontal line, remember, this line right here is horizontal. And this line here is vertical. And for the vertical one, we call it y. For the horizontal one, we call it x. Remember, x always comes before y. So the second coordinate gives the vertical location. A number in an ordered pair x coordinates, y coordinates. So we call it x-axis is the whole line, horizontal number, and y-axis is vertical line. So origin, as I said before, the origin is where it's intersect with the point 0, 0. And quadrant, we're gonna say it. Quadrant is the fact that your graph, not your graph yet. So your rectangular system, that we call it Cartesian coordinate system, or XY plane, we can call the whole thing here XY plane. When you put like this cross, you see, because it's not only a cross, it's because you have a horizontal and a vertical axis intersect at the origin. Now you see when they cross, it creates four different sections. Let's suppose this is, if you put it in a box like this, so you will see there are four different sections. So if you go counterclockwise, this is one, this is two, this is three, and this is four. And each of these sections has a name. The first one, as you see, I move counterclockwise from the positive value of X and positive value of Y. So we call it quadrant one, then we have quadrant two, we have quadrant three, and quadrant four. Of course, this is something we're gonna see in a different place. To graph the point corresponding to a particular ordered pairs, X, Y, you must start at the origin and move X units to the left or right, left, right for X. And I mean, if X is positive, you move to the right. If X is negative, you move to the left. Then you move Y units up and down. So let's suppose we have in X coordinates like this, X and Y plane. And remember, in that XY plane, we have two coordinates, X and Y. So the first number is 2 and the second number is 3. So that means in this one, what you need to remember is that X is 2 and Y is 3. Now remember, this is Y and this is X. From the origin right here, that is 0. Because both of them positive, I'm gonna move 1 and 2. This is the X value, and the Y values would be 1, 2, and 3, right? So if I intersect with these two, where they would intersect, these two would intersect right here. This is the point 2, 3. In the same XY plane, if I want, I can even put other coordinates. Let's suppose, for example, they ask me to do negative 1, 2, for example. Negative 1, 2. Remember, if X is negative 1, we go in this way, and Y is 2. So you see the intersection between negative 1 and 2 is right here. Or they could ask me to graph maybe negative 2, negative 3. So both of them negative. X is negative 2 and Y is negative 1, negative 2, and negative 3. So you see, putting it right there, this would be my negative 2, 3. So I just show you this because we're going to have a lot of time to do more examples. But what the book says, the book shows you the XY plane, because in this case you can see the XY plane with the quadrants. Remember, we moving counterclockwise, and you can go this way to counterclockwise. So quadrant 1, quadrant 2, quadrant 3, and quadrant 4. What happened in these quadrants that you need to remember, in the first quadrant, X and Y are always positive. So X positive and Y positive. The coordinates are positive. Suppose, for example, they ask you to write to here, you see both digits positive. If I said 1, 2, 1, 2, this is a point 2, 2. It's in the first quadrant because both numbers are positive. In the second quadrant, as you can see, the first number is negative because below 0, remember the origin is right there, below 0, then X on the horizontal axis is negative. So, for example, if they give you negative 3, 3, or negative 3, 2, let's do negative 3, 2. You see, because in the second quadrant, X negative and Y positive. So you have these two numbers, one of them negative, but that would be the first digit. So if X is 1, 2, and 3, so negative 3 here, and 2 is right there. So you see, that would be where I would put my negative 3. To look at the sign, the first coordinate is negative. In the third quadrant, as you can see on the left, below on the horizontal axis, that means below the intersection, that is zero, below the origin, that is zero, x is negative. And on the y-axis, below zero, y is negative. So we have in this quadrant, the third quadrant, x negative, and y is also negative. So you have two negative numbers. For example, if they ask me to graph -2, -5, I did a -1, 2, 3, 4, and 5. That's -5 here. -2, remember it was right there. So that will be the number for -2, -5. You see, both numbers are negative. Now, on the fourth quadrant, we go back where x was positive, above the origin. So, but the same time, it's still below the origin for y-axis. So in this case right there, on the fourth quadrant, x is positive and y is negative. Remember, we said the first coordinate is x and the second coordinate is y. So if we need to plot the point 2, -2. This is -2 right there. So if we go with 2, that will be here. We have 2 here. Okay, so that's what happened. Now, note that the order of the coordinate is very important. Since -4, 2, and 2, -4 are located in different positions. Remember, you cannot switch them. The first coordinate will always be x, and the second coordinate would always be a y, all right? So don't forget from that each ordered pair corresponds to exactly one point in the plane, and that each point in the plane corresponds to exactly one ordered pair. So that's what we said like here for you to remember. Pause the video if you want to read it. We're gonna start with plotting some points on the XY plane, or we can call it Cartesian coordinate planes or rectangular system. So the first point A, x is 1, 2, 3, 4 right there, and y is 2. So if we show where we're gonna connect, this is where we put A. And B, you have -3, x is -3 right there, and -2. That would be B. C, x is 2, y is -3. Let's see. As you can see, now A falls in the first quadrant. Remember, quadrant 1 is right there. Quadrant 2 is here. Quadrant 3 is here. Quadrant 4 is here. So remember, in quadrant 1, both coordinates are positive. In quadrant 2, the first coordinate negative. In quadrant 3, both coordinates are negative. Remember that quadrant 1 and 3 has same sign, but quadrant 2 and 4 has different sign, but it would tell you which one you should. Now, when one of the coordinate is 0, you fall on the axis. You don't fall on a quadrant, but you fall on an axis. For example, D, where x is 0, that means 0 to when and y is 4. This is where we're gonna be. We're gonna be on the axis up there for D as in dog. Okay, we're gonna put D right there. Okay, now the next one we'll see x is way 5 and y is 0. So we're gonna have E in this area right there because it's on the axis. So remember, 4, 2 is in quadrant 1, -3, -2 is in quadrant 3, 2, -3 is in quadrant 4, 0, 4 is in y-axis, and 5, 0 is on x-axis. But how to determine whether an ordered pair is a solution? So it's very important to verify that. They said determine whether 2, negative 3 is a solution to the equations. The first thing to do is really rewrite the equations they give you. 2x plus 5y equal negative 4. From the ordered pair they give you, make sure you identify the first coordinate as x and the second coordinate as y. That means x equal 3, y equal negative 2. Now, if you substitute from this one, so everywhere you see x, you would replace it by 3, and everywhere you see y, you would replace it by negative 2. So you have 2 times 3 plus 5 times negative 2 equal negative 4. Now, after you simplify, you distribute and you simplify, if you find the left side equal the right side, you would conclude that ordered pair is a solution to the equation 2x plus 5y equal negative 4. So let's go with 2 times 3 is 6, plus 2 times negative 2 is negative 10 equal negative 4. So 6 minus 10 equal negative 4. Negative 4 equal negative 4. Check. So once I do that, I can conclude, yes, the ordered pair 3, negative 2 is a solution to, I said of 2x plus 5y equal negative 4. If we substitute for x and y and the answer, the left side was not equal to the right side, we would have concluded that it is not a solution. Now, determine whether negative 1 and 6 is a solution. Remember, and the same equation may have a multitude of solutions. Doesn't mean it's going to have only a unique solutions, all right? It can have more than one solutions or no solutions. Now, look at this one. If we have x negative 1 and y 6, so x equal negative 1, y equals 6. Now, in the 3x minus y equal 5, we're going to verify if the left side equal the right side. So 3 times x, that means 3 times negative 1 minus, you see, I put a parenthesis 6. I prefer you always put a parenthesis just in case you don't master sufficiently your sign, your operations on sign. So 3 times negative 1 give you negative 3. Negative 6 equal 5. That should be negative 9 equal 5. Is it true or false? Negative 9 would never be equal to 5. That is totally false. So would you consider the ordered pair negative 1, 6 a solution of the equation 3x minus y equal 5? No, no. We're going to say no. The ordered pairs negative 1, 6 is not a solution of 3x minus y equal 5, okay? Apologize for the noise. I'm not too far from an airport, so that's why you can hear all of this noise for now. So I apologize for that. All right, now let's see a few other examples we can do, especially because now you know how to plot points on the XY plane or Cartesian coordinate plane. So we think we're ready to really graph linear equations. But what is linear equations? Linear equations is an equation in two variables. Okay, linear equation in two variable is an equation that can be written in the form ax plus by equals c. Remember, we said two variables. Variables 1, that's the first variable, and variable 2. Okay, So we have two variables. Now, that's why we say two variables, okay? We said two variables, X and Y, they are variables. A, B, C, even though we have a combinations of letters, but those letters, they don't mean the same thing. A, B, C in here are real numbers. I mean, they are constant. They are numbers that we would know, that would be given, but XY would be variables. I mean, we need to look for them. We need to solve for them, okay? So this form is called standard form because we have different forms. We have a variety of forms, but anytime you see any equations on the form AX plus BY equals C, we call it a standard form. For example, 2X plus 3Y equal 5. That's an example. Negative X plus 7Y equals 0, or you can have 5X minus Y equal negative 10, etc. So I give you a few examples where you would see the equations at the end have only X and Y, A, B, C, substitute for real numbers. Graph the linear equations you can see here. So what they're gonna ask us to do is really graph. We need to graph. So what we're gonna do in graphing, very important that we graph. We're gonna do our best with graphing those. So graphing for us, first of all, we must have an XY plane. I'm gonna construct a very decent XY plane where the horizontal line is X and the vertical line is Y. Remember, if it's intersect at 0, I can do 1, 2, 3, 4, 5, 6. I know my scales are terrible, but please accept my apology for that. -1, -3, -4, -5, etc. -1, -2, -4. See? So having all of this this way, what we can do, uh, since the equation is solved for y, we should choose values for x. To evaluate fraction, we should always take numbers that would make it a whole number. For example, the first thing we need to realize here is a linear equations. A linear equations has, for graph, a line. So there is no curve. You don't need to turn right, left, etc. It's just a straight line. Now, the line can be horizontal, vertical, or oblique, like a diagonal. Now, we can construct a table because we're looking for one or two or three or 5 points that has the first value X and the second value Y. So if we construct a small table where we're gonna call one column X, the other column Y, let's see. We can say if X is 0, what's going to happen for y? Look, if x is 0, y would be 3/4 of 0 plus 3. Any number times 0 is 0, so you're going to have 0 plus 3. That's y would be 3. So when x is 0, y is 3. So I would consider I have my first point, x0, y3. Where is that? I can put it when x is 0, y is 3. I can put the first point right there. Now, because it's a straight line, I only need 2 points, right? Now, the other points I might see, because I don't want to deal with fractions. I'd like to get to find something when I multiply by 3 and divide by 4, it gives me a whole number. So the first number I can see close here that would do that is 4. So when x is 4, look what happened with y. So y equals 3 times 4 over 4 plus 3. If you want to cancel, that's fine. You can cancel by 4, so you're going to have 3, or you do 12 over 4 plus 3. 12 over 4 is 3 plus 3 is 6. So when x is 4, y is 6. Okay, this is what happened. I think I need another one, 6. You see, X is 4, okay? If X is 4, see, this is it. We already have enough points to graph. Of course, we could always, if you want to make sure you get it correct, you can put -4. If X is -4, look at Y. Y would be 3 times -4 over 4 plus 3. That would be -12 over 4 plus 3. That would be -3 plus 3. That would be 0. So X -4, Y would be 0. So we're going to have a point. Remember the points for us. The first point is 0, 3. The second point is 4, 6. The third point is -4, 0. So when we plot these points, all we need to do is to connect those dots. Those dots will give us a very straight line. If you want, you can even use, you know, this ruler, because the ruler helps us to make a straight line, but I trust you to do it even without the ruler, okay? Right? So if you want a graph, we just go, this is our straight line. Good, right? And we can continue. We put the arrows to say, oh, you can continue indefinitely. So doing so, we said, you know what? We're going to continue indefinitely. So that's what it means when we graph like that. But of course, you don't need all of these computation I made here. You can just get rid of them. Now, you see this one as well. They ask you to graph the first thing to do, because once you do the first one, the others become easy. Remember, you have X here and Y here at the origin. You have 0. When you construct a small graph, you need 2 points because it's a linear graph, If X is 0, if you set X equals 0, what would be Y? 2 times 0 minus Y equal -4. So we're going to have -Y equal -4. Always make it positive. If we divide both sides by -1, and you see Y would be 4. So when X is 0, Y is 4. So that's the first thing you need to remember about that one. Okay. And now we're going to say the same thing for the next one. We can take, when X is 0, Y is 1, 2, 3, and 4. This is the first point we have. And when X, okay, we can take any of this. You know what? How about if Y is 1, or because this the way we have it, if Y is 1, so we're gonna have 2x minus 1. No, we're gonna take something different. Let's say if Y is 0. We want to substitute for X instead. If we want to substitute for X, we can do that. But let's say if Y is 0, so we're gonna have 2x minus 0 equal -4. 2x equal -4. Divide both sides by 2, x equal -2. So when Y is 0, okay, x is negative. So you end up with 2 points here, 0, 4, and -2, 0. -1 and -2. And this is your second point right there, that we can do -2, 0. And this one is 0, 4. All right. So if you graph, you can use the ruler, or I can show you. Remember, the line must be very giantly straight. Okay? It's a very straight line when you do this. We're gonna be happy with it. Okay. That's one of the examples. So we have ordered pairs where you use 0. We do 0, 4, and we have another ordered pair where we do -2, 0. So we can choose either of these to do that. All right. Other questions we can ask you to do. All right. in this, when graphing a linear equations into variable, if it is solved for y, it may be easier to find ordered pair solution by choosing x value. Okay, if it is solved for x, it may be easier to find ordered pair solution by choosing y value. So you choose what to do. Okay, if a graph crosses the x-axis at 2, 0 and the y-axis at 0, 8, then we call that intercepts. So that's the other things we're gonna study. Notice that for the x-intercept, the y is 0, and for the y-intercept, the x is 0, because that's what I just did with the previous examples. I set x equal to 0, I obtain y, and then I set y equal to 0, I obtain x. We call that intercepts. Sometimes mathematics, you may see just the number -8 state as the y-intercept and 2 state at the x-intercept, because the other ones is 0. So how to find the intercepts? I think that's one of the topics we need to cover. That's help us a lot to go faster with graphing those type of equations. Okay, so to find the intercepts, you let x equal you let y equal to 0 to find x-intercept. For example, if I have an equation 3x plus 2y, I'm gonna say minus y, minus 2y, minus 2y equals 6. To find x-intercept, what I'm gonna do to x-intercept, set y equal to 0 to find x-intercept. So that means we need to solve for x. So 3x minus 2 times 0 equals 6. What's going to happen next? We have 3x minus 0 equals 6. So 0 is gone. And if we divide both sides by 3, so you see x equal 2. So this value right here is the x-intercept. Or you can write it in terms of ordered pair. That means x is 2. What is y? 0. Okay. Now to find y-intercept, you let x equal to 0. For the same equations, if I let x equal to 0 to find y-intercept, right? That's what we do. We said 3x, 3 times 0, because x is 0 now, minus 2y equals 6. 3 times 0 is 0, so we have negative 2y equals 6. 0 minus 2y, so we move. So divide negative to both sides, because you cannot say negative y. So you have x equal negative, y equal negative 3. So this is the y-intercept. You can always say y equal negative 3 is a y-intercept, but it's intercept with the y-axis. It's on the y-axis, or you can write it in terms of ordered pair. Remember, ordered pair has two numbers, one in the middle. Let's say the same way you do for x right there. So what would be x? 0. When x is 0, y is negative 3. You see, you have these two numbers, and that would be enough to graph a linear. We can graph a linear equations with that, okay? Let's see some other examples. They said graph. We can graph these two very quick. If you graph them very quick, it would help us to, if we do the intercepts, because this is what you have, 2x equal y, okay? Now, let's see. Using by finding and plotting the intercepts. What's the x-intercept? If x-intercept, how to find x-intercept again? Yes, you set y equal to 0. So you have 2x equal to 0. If you divide by 2 from both sides, x 0 over 2 is what? 0. So you have your first point 0, 0. So x is 0, y is 0. So there is nothing else you can do. And y-intercept, what happened to find y-intercept? Yes, you said x equal to 0. So 2 times 0 equal y. So what you say, 0 is equal to y. Again, you have that ordered pair, 0, 0. So even though they ask you to plot the intercepts, the problem here is not a graph yet because both intercept is at the origin 0, 0. So if you want to graph, you should choose at least another number. Like, let's say if x is 2, what would be y? 2 times 2 is 4, so y would be 4. So we have another point, 2, 4. Yes, that would give us a graph. So when x is 1 and 2, y is 1, 2, 3, and 4. Right there. Okay. So this is this graph going. We know the direction of the graph because going through the origin, it could also go like this, that we don't want to happen. Okay. So we want to make sure which direction it goes. Is rise from left to right. Okay, these equations rise from left to right because otherwise, if you had negative 2x equal y or y equal negative 2x, it was going to fall from left to right by passing through the origin. All right. So, as I said, notice that anytime 0, 0 is a point of the graph, then it is an x-intercept and a y-intercept. So this is the only point that lies in both axes. So remember that. That's why they use that one, okay, for you to make sure you can see what's going on with it. All right. So very giantly important. Now, how to graph non-linear equations, because the three examples we just go over, as you can see, they are linear. Linear means a very straight line. Now, we need to graph a different type of equations, and these equations, we call it a parabola. The parabola is in this format, like we call it quadratic equations, because parabola is from the quadratic equations that we would cover later. Quadratic equation of functions. Let's say functions. I'm gonna say functions. It's y equal ax squared plus bx plus c. So for a type of graph, anytime you have power 2, like remember a cannot be 0, right? So cannot be 0. So if a is 0, then you don't have a parabola anymore, right? So for this type, parabola can be open up or open down when you have y equal x squared, when the x squared is the dependent variable, okay? Now, for this graph, what you need to remember, we can construct a table. So what's a parabola? Parabola has a U shape. It's either open up if the coefficient, the number in front of the xy here is positive, or that means if a is positive, it's open up, or if a is negative, it's open down, right? If a is like -1, -2, or something, it's open down. But as we did with the previous one, the most important part is to construct a small table with numbers to obtain the ordered pair. Because I have y equal x squared, I'm interested to take some numbers. Like I'm gonna do it between -2 and 2, -1, 0, 1, and 2. I could do -3 and 3, no problem. You know what? How about we add -3 and 3, okay? So to see how big it's gonna be, because I'm not sure we can do it. When x is -2, y, look, if x is -2, y would be -2 power 2, that's give you +4. But when x is, I'm gonna just, because I don't wanna go up to 9, okay? The same way, if x is only 2, it's gonna power 2, give you 4. So for this one also is 4. Now, if x is -1, you're going to have -1 power 2 is 1. But the same negative, if you take 1 power 2, it's gonna give you 1. So negative 1, 1 give you 1. And if x is 0, y equals 0 power 2 is 0. So the only, you see negative 1, 1 give you the same y coordinate. Negative 2, 2 give you the same y coordinate. Even though you said negative 3, 3 would give you the same. But what happened with parabola, remember it's a U-shape, there is a turning point that we're gonna call vertex. So that's something we're gonna study later. But now let's plot our points. When x is negative 1, negative 2, y is 4. 1, 2, 3, and 4. When x is negative 1, y is 1. When x is 0, y is 0. When x is 1, y is 1. When x is 2, y is 4. Now, looking at this, we can plot those points, you know. Now, I only take negative 2, 2. Doesn't mean that's our limits. We can do it indefinitely. If you want to connect 10 or negative 10, 20 or negative 20, it doesn't matter. So I'm not going to stop at the point negative 2, 4. I can say, you know what, this one would continue indefinitely on both sides. I show the graph can continue indefinitely in both sides, and that's how I'm going to show it. Now, you graph linear equations. Now we start graphing non-linear equations, and the first one is a parabola, it's a quadratic equations. The absolute value functions as well give us a different shape that is not linear. So remember, absolute value of negative 2 is 2, absolute value of 2 is also 2. Now, if you construct a small table with x and y, let's suppose we go between negative 3 and 3. Those are numbers I take randomly. If you want to do different numbers, that's fine, you know. But I want, when I plug that negative to, because I know y equal absolute value of x. If x is negative 3, absolute value of negative 3 is positive 3. Absolute value of negative 2 is 2. Absolute value of negative 1 is 1. 0 is 0. 1 is 1, 2, and 3. So I have all my coordinate. When x is negative 3, y is 3, is a positive 3. When x is negative 2, y is a positive 2. When x is negative 1, y is a 1. 0 give us 0. We could continue going down, but we're gonna go, when x is 1, y is 1. When x is 2, y is positive 2. When x is 3, y is positive 3. Now, when you look at this one and we connect the dots, and it gives us a V. Okay, take this one as a V. Now, no curve, okay, no curves, no smooth curve like we do with the parabola. The parabola has a turning point, it's a smooth curve. But this one, the vertex, I mean, the turning point is just sharp, okay? So it's a absolute value functions, but we don't need to stop at 3, negative 3. I just take those numbers. If you want to continue indefinitely on both sides, yes, you can, okay? That would give you a V. V shape is for absolute value function. U shape is for power 2. Now, some other graph you might see also, and we can just plot points if they ask you to graph for square roots. Okay, so that's another non-linear equations you can graph. I can take numbers. What do you think I can take negative 3, negative 2, negative 1, 0, 1, 2, 3? No, I cannot take any negative numbers here because square root of a negative number is undefined. So, I mean, not a real number, but I'm gonna take only positive, like 0, like 4 when x is 4, when x is 0. Square root of 0 is 0. Square root of 4 is what? 2. Thank you. Square root of 9 is what? 3. But I'm not sure I would need those because 0, 0 is right there. When x is 1, 2, 3, and 4, you see y is 2. And when x is 5, 6, 7, 8, and 9, y would definitely be 3. So you see this is the shape we're going to have for our graph. And we call this one, it's a square root functions, right? Now, we have plenty of these we can do when they ask you to graph those type of equations. Construct a table is your best bet. You make sure really you construct a table before you even start plotting points because that's help you to avoid mistakes. In a different video, we're gonna come back really with the second sections, that is introduction to functions. So you have fun and let me know if you have any questions. Take care.